Chapter 6.4 is on rectangles, and a rectangle is a quadrilateral with 4 right angles. You can see here we have a right angle at U, R, S, and T. This here is a rectangle. And a rectangle has all the properties of a parallelogram, meaning opposite sides are parallel, opposite angles are congruent, obviously because they're all right angles, and opposite sides are congruent, and consecutive angles are supplementary. So a rectangle is a special type of parallelogram, which is a special type of quadrilateral. And then we have a couple of theorems. We have the diagonals of a rectangle. If a parallelogram is a rectangle, then we can say or assume that its diagonals are congruent. And then we have the flip side of that, or the inverse of that, where if we have the diagonals of a parallelogram are congruent, then we could say definitely that the parallelogram is a rectangle. So we're going to use these theorems to solve some problems. And let's go ahead and look at exercise number 1 here. Let's do this exercise number 1. So a rectangular park has 2 walking pathways here from P to R and S to Q. If PS is 180 meters and PR is 200 meters, find QT. Okie dokie. So since we have a rectangle here, and a rectangle is a parallelogram, and diagonals in a parallelogram bisect each other. We learned this in 6.3, the previous chapter. And PR is 200 meters. And then we can say that the diagonals are congruent because it's a rectangle. Right? Given that the park is a rectangle, so diagonals are congruent. So that means QS is equal to 200 meters as well. So we'll say QS is equal to 200 meters. So then if we're trying to find QT, well, we also know that diagonals bisect each other, right? Which means that this side is congruent to that side. And so that can only be the case is if QT is equal to 1/2 QS. Right? So QT is equal to 1/2 times QS. So we'll go ahead and substitute in. And we'll get 1/2 times 200 is equal to 100, and that's the length of QT. All right, so let's look at this next problem here. We have quadrilateral JKLM is a rectangle. If this angle, maybe I could draw it out here. So let's do JKLM. So if KJL, okie dokie. So we have this diagonal here, JKLM, yes. So we have KJL. This angle here is 2x plus 4. And then we have the angle JLK is this angle here is 7x plus 5. We're trying to find x. Okay, so one way that we can solve this problem is we can say that if JK is parallel with ML, then that means that these two angles are alternate interior angles. So they're the same. Right? And in a rectangle, we know that every angle is a 90-degree angle. So we can say this angle here plus this angle here is equal to 90 degrees. Okay, so let's go ahead and do that. Let me write it out first. So I'm going to say measure of angle JLM is equal to KJL. Measure angle KJL, and that's because of alternate interior angles. And then from there I could say that KLM, so I'm going to say measure angle KLM is equal to the measure of angle JLM plus the measure of angle JLK, like so, right? So this big angle here is equal to this small angle plus that angle there. So let's go ahead and substitute in all of our expressions and solve for the measure of, oh, what are we trying to find? Of x, okay. So KLM is equal to 90 degrees. JLM is equal to KJL, and we have KJL here. So we're going to put 2x plus 4. And then we have JKL, which we have here, plus 7x plus 5. So we'll do the math here. We'll get 9x plus 9 is equal to 90. And we'll get 81 is equal to 9x, which leaves us with x is equal to 9. And we're done. So we're going to go ahead and use these properties of rectangles to solve different problems. And remember that a rectangle is also a parallelogram, and so also abides to these properties here. So let's go and use those to solve problems 1A, B, and problem number 2.